Good morning, good afternoon, good evening, or good night. In the Hydronic circuit entry video, we have looked at the circuit wizard from a high-level perspective. We have seen how to follow the steps and how to look at the different input screens. In this video, I want to go more into detail about the different hydronic circuits you are able to use in the project calculation and be specific about the different information that will appear. As already said, there are around 50 possible hydronic circuits available in HySelect. We have structured these in this video for practical reasons into different groups. Feel free to fast forward to the specific circuit you are interested in. For more theoretical background about the hydronic circuit themselves, I highly recommend to look at the balancing and control boosting training material from week 2. Let's first of all look at the pending circuit. Pending circuits. When you add a pending circuit, you should provide the total flow that will circulate in that circuit to be added at a later stage. And ideally, the differential pressure and pipe length. Distribution circuits. Different types of distribution circuits are available in HySelect, depending on the choice for manual balancing, differential pressure control, or electronic DP control. Let's take a look at the different circuit wizard screens for all options. Distribution circuit with manual balancing. Here there are 5 tables to look at: terminal unit, balancing valve, circuit pipe, distribution pipe, and the information table with primary calculated values. In the terminal unit table, you are able to enter a description, enter the flow, and even with power and delta T, and the differential pressure. For differential pressure, there are 4 options. Or you enter the dP immediately, or with QREF and dPref, what is often mentioned on the technical data sheet of terminal units, or with the kV or CV value when using imperial units. The balancing valve table will be completed automatically after completing the terminal unit tab. You are able to filter the selected product by clicking the plus and selecting. The dP calculation is in function of the balancing for the complete hydronic module. By locking this table, you lock the selection of balancing valve, so the end size and type, as marked in bold. But calculation for dP will update according to the further project calculation, of course. In the circuit pipe and distribution pipe table, you fill in the values as seen before. The pipe sizes and dP will be calculated according to the installation flows and technical parameters. Once locked, the DN size and pipe series will not change, but the dP of course will. Now we will have a look at the accessories pop-up menu. Click the 3 dots next to accessories. Notice that in circuit pipe there are already 2 accessories automatically added. These are the 2 elbows to make the turn to the terminal unit. Accessories can be added with 5 different information types: QREF dPref, the singularity coefficient, the zeta value, the equivalent pipe length, CV or kV. Add a description. Add the values, click, and you'll notice that the Add button becomes bold. By adding the accessories, the dP will automatically be recalculated according to its values and the flow rate. There is an option to change the amount and to modify or remove the accessory. In the primary values table, the calculated values for temperatures and flow and available head will appear. Distribution circuit with differential pressure controller. Compared to the distribution circuit with balancing valve, there are now 2 tables that are different: the dP controller and the balancing valve table. You'll notice the case measuring valve in for the balancing valve. Here you define if the differential pressure of the balancing valve is included in the DPL or not. Remark the difference in the drawing. The balancing valve is calculated for the minimum differential pressure set in the technical parameters, here 3 kPa and design flow. The DP controller will ensure the balancing and DPL.
The last option for distribution circuit is the electronic DP control. So here we will select the TIA Smart DP to ensure the differential pressure for the circuit. In sets, you are able to select the DP sensor set 10 to 100, 40 to 400, or simply a connection set without sensor. The DP of the valve and the minimum DP are calculated here with kVs and flow rate. Two-way control circuits. Different types of two-way control circuits are available, depending on the control type, balancing type, and control valve type selected. The control type will impact the actuator and the valve characteristic selection. You'll notice that different options become available when choosing proportional or modulating control. The control valve type will impact the type of valve selected, standard two-way, adjustable, combined like TBVC, PIBCV or Smart. Let's take a look at the Circuit Wizard input screen for two-way control in general first. The tables for two-way control are similar to the ones in distribution circuit, but now we have added a table for control valve. The selection and minimum DP here will be related to the settings in technical parameters. In the case of a control type modulating control, you'll notice the authority calculation as well. There is an option to select the two-way control circuit with on-off, control valve and differential pressure controller. The additional table for DP controller is there now and the choice for balancing valve included or excluded in the DPL. See the difference with adjustable and measurable control valve. Here the result will be TBVC with DP controller. When clicking the arrow next to the actuator selection, a pop-up screen appears and you are able to make a finer selection. As mentioned, the control valve table now shows the minimum authority. The selection is made according to the settings in project parameters. Notice the option for DP controllers on a two-way control circuit when selecting proportional control. This will be either DP stabilization over the branch or the control valve to improve authority. The pressure independent selection gives you PIBCV, and when selecting electronic balancing, you are able to select TA Smart. Two-way injection circuit. When selecting a two-way injection circuit, there are more tables to complete. Terminal unit. Here we now need to add the delta T additionally, since this could be a different value than on the primary. The balancing valve is the balancing valve on the secondary. Will be selected for 3 kPa and nominal secondary flow. Secondary values, this is the supply temperature for the secondary coil. Imagine underfloor heating at a lower temperature. The TRS will be computed with the information of delta T in terminal unit or with the averaged return temperature when this is a distribution circuit. Complete the secondary pump head when known in the pump table. Minimum needed head will be calculated. The secondary table is information on the pipes and accessories on the secondary side. Otherwise similar to a standard two-way circuit. Three-way dividing circuit. Three-way dividing circuit. Here you will get a three-way control valve selection and the selection for the balancing valve in the bypass. The logic here is that an overflow is calculated. This is the theoretical overflow that would exist when there is no balancing in the bypass. So linked to the available differential pressure and the terminal unit differential pressure. When the theoretical overflow goes above 20%, automatically a balancing valve will appear. Click on the case next to the table to add a balancing valve even when not automatically presented. Three-way mixing circuits. Here, two balancing valves need to be selected. One for primary, one for secondary, so two cases. And remember, we always calculate based on active primary. There is a calculation for H min on the secondary, together with flow. Enter the head of the pump when already known. Besides that, all the same rules apply as for the two-way direct circuit, except that the valve selected will be a three-way valve. Three-way mixing with decoupling bypass. The information to be completed here is similar to the three-way mixing, with that difference that you need to specify the localization of the control valve. As we know that the three-way mixing on an active primary could have some drawbacks, think about interactivity for example, we could select a three-way mixing with decoupling bypass instead. On-off proportional or three-point control with manual balancing or differential pressure control and standard control valve lead to this option. Let's take the example of proportional control, manual balancing and a standard control valve here. Two possibilities. One where the three-way is part of the primary circuit and one where the three-way valve is part of the secondary circuit. You will notice that this will impact the DN size of the valve. We will look at both cases. Similar to a two-way injection circuit, we will need to complete the secondary circuit information as well. Complete the thermal units information, the secondary values like temperature. TRS will be computed with the average return temperatures if this would be a distribution circuit with other terminal units. Complete the information for the head of the pump when already known. H-min and flow are calculated. Remark the option to change the localization of the control valve. Here we see three options. Automatic, on the primary or on the secondary. The logic behind automatic is to be able to select the smallest size valve. So when the primary flow is smaller than the secondary, the valve will be put in the primary section. If flows are equal, it will be put on the secondary side. Look at the difference in the drawing, see the colors changing and the impact on sizing. You are able to fine-tune the control valve selection by clicking the plus or changing the actuator by clicking the drop-down arrow. The last cases to check are the two balancing valves. The balancing valve for primary will ensure balancing on the primary side. The valve on the secondary will ensure nominal flow, so minimum dPa like 3 kPa when the pump head can be adjusted to the strictly minimum, or the valve will take the excess pump head. Remark that by changing the control valve's localization, we've automatically jumped to the other circuit type of the first wizard step. Auto-adaptive variable flow with decoupling bypass. This circuit is a bit special and one of the last that have been added to this HySelect circuit calculation. The idea here is that the DP controller keeps a constant very low flow through the bypass, creating variable flow depending on the circuit's needs and being able to reduce the secondary pump head, because the primary pump head is used. For more information, check the Balancing and Control Week 2 boosting material. You will find it by selecting None for control types and differential pressure control for balancing. 8 tables in this window to look at: terminal unit, circuit pipe, distribution type, and balancing valve secondary are the ones we already know. In this case, the balancing valve on the secondary will be calculated to take the excess dP. In the table for pump, you now find H available, so from primary, and H min. When there is already enough differential pressure from primary, this case remains empty and remark pops up. When the needed pump head is higher, H min is added. This H min is the setting from the technical parameters section. Complete the head when already known. The balancing valve and the bypass will always be a small one to deliver the differential pressure to the secondary. The dP controller is selected to deliver the constant dP for the circuit. So with this, we went through all the different main types of circuits that are existing. And you might notice that I didn't discuss all 50 circuits. This is simply because these are variations to the ones we saw in this video, and so the same logic will apply. But do not hesitate to reach out when you have questions or when you didn't find a specific circuit you were looking for. The last option I would like to discuss is the selection with control valves with KVS values. In the first step of the circuit wizard, you will find the work for control valves with. Here you can distinct to simply work with KVS values, so not specific to our valves. This could be the case in a renovation or when the project asks control valves that are not in our portfolio. Let's look at the two-way direct circuit with proportional control and manual balancing as an example. The biggest difference will be in this control valve table. Here you are able now to add a description, like control valve manufacturer X, KVS 4. Change the value of the KVS when already known or selected. And you'll find the dP at KVS and minimum authority calculated. Let HySelect define the KVS value when not selected before. Locking the table will lock the KVS value. The minimum authority will show in red when it's below the desired value stated in the technical parameters and will be listed in the HYDRONIC calculation output as well. So, here with some more detailed information about the different hydronic circuits in HySelect. The most important intel to remember is circuits display according to the selection in the first wizard step. So take care when taking this first step. In the second wizard step, the cases are adapted to the specific circuit. The outcome is always related to the input in the technical parameters. And practice makes perfect. Good luck with the project calculation HySelect and see you in one of the next videos.